In the name of God, hello dear students, my name is Masoud, I'm a physics teacher. We are in Ferkhwa's website to explain physics curriculum, grade 12. Right now I'm going to explain new subject, which is centripetal acceleration, and we denote it by AC, A sub C. Right, let me read the definition of this, let's say, quantity for you. So centripetal acceleration is the time rate of the variation of the direction of velocity when it moves on a circular path. Time rate means, let's say, divided by time, right? Time rate of the variation of the direction of the velocity when it moves on a circular track, right? So it says it's a time rate, means this acceleration, of course, and any type of acceleration is taking place in a particular time interval. That's why we say time rate. Time rate means divided by delta t. Variation of, let's say, variation of what? Variation of direction. It doesn't, let's say, variation of magnitude of velocity. It says variation of, let's say, direction of velocity causes this type of acceleration. What does it mean? It means whenever the object moves around the circle, so it picks up this type of acceleration, whether the magnitude of velocity changes or not. What do I mean by magnitude of velocity? Magnitude of velocity means speed. Whether the object speeds up or slows down, it doesn't matter. So because the object moves around the circle, that's why it changes its direction continuously, right? You know, any object, let's say along a circular track, changes its direction continuously. That's why it picks up centripetal acceleration automatically, right? Like what? Like the first example, moon orbits the earth. This is moon. Moon orbits the earth, right? Whether the speed of moon, whether the magnitude of velocity changes or not, it doesn't matter. As long as it moves along a circular track, that's why, without thinking, so automatically, it doesn't, let's say, need to think about it. Without thinking, because it moves around the circular track, so it picks up centripetal acceleration. So it has centripetal acceleration. And centripetal acceleration, right, is the only type of acceleration that is created only by the change of direction, not change of magnitude of velocity, change of direction of velocity. And whenever you say centripetal, means it moves toward it moves toward the center of a circular track. This is circular track, actually, right? This is circular track, and this is the center. So it moves toward the center, right? It's directed toward the center of the circular track. The second example, a car moves along a circular track. So there's a car here, right? The car, I can say, moves around a defile, actually. There's a defile. The car moves along a defile. And defile means a curved path. That's why it picks up centripetal acceleration. Whether the, let's say, whether the car speeds up or slows down, it doesn't matter. So I can say AC is independent of magnitude of velocity. AC only depends on the direction of velocity, and centripetal acceleration only exists in circular track, right? So it's dedicated only for circular track, not for the other, let's say, other paths, right? Here there are some tips. The first step, let's say read it for you. The first step, it says any object moving along a circular path, right? Any object moves along a circular track has AC. It picks up AC automatically because it moves along a circular track, right? Regardless of the magnitude of its velocity. What's the meaning of magnitude of velocity? Means speed, regardless of vt, for example. Regardless of magnitude of velocity means regardless of its tangential velocity, whether it moves in constant velocity or let's say varied velocity, no problem. So it possesses centripetal acceleration. The second tip for an object moving in a circle with, look here, with constant tangential velocity. So magnitude of velocity does not change, right? The car circles the square, or the car or any object orbits the circular track at the same rate without changing the magnitude of velocity, without increasing its velocity, without decreasing its velocity. AC still exists, but AT becomes zero. So when the object moves at a constant speed, in this situation, because Vt is constant, so whenever Vt is constant, AT becomes zero, because AT is equal to what? Look here. AT is equal to delta T, delta Vt divided by delta T. AT, let's say AT is due to what? AT is due to the change in tangential velocity, right? But the tangential velocity or tangential speed is constant here in this situation. So Vf and Vi becomes the same number, right? What does it mean? The object moves with a constant velocity. So in this situation, acceleration does not exist. But which type of acceleration? Centripetal acceleration or tangential acceleration? Guess the answer. Of course, let's say you guessed the right choice. A tangential acceleration becomes zero. Centripetal acceleration never becomes zero, because let's say whenever it moves along a circular track, automatically it gains this type of acceleration. That's why AC never becomes zero, but AT becomes zero sometimes. AT, let's say, sometimes becomes zero, sometimes not. In which situation AT becomes zero? In the case of constant velocity, in the case of constant tangential speed. So AT becomes zero. Keep in mind that AC never becomes zero. AC never becomes zero, but AT, it can be. In which situation AT becomes zero? In the case of constant tangential velocity, right? In what situation AT and AC exist together? In which situation? When the object moves along a circular track and changes its velocity and changes its speed, let's say. The object speeds up. Teacher, only speeding up, let's say, causes tangential acceleration? No. It's slowing down as well. So when the object slows down along a circular track, so without thinking, AC exists because there is a circular track, right? But AT, I say the object slows down. What does it mean? Means the speed is reducing in this situation. So any change in speed means acceleration. But which type of acceleration? Tangential acceleration, right? So increasing or decreasing speed causes what? Causes tangential acceleration. But changing the direction causes, let's say, centripetal acceleration. This is the second tip. The third tip, AC never be zero. I told you, AC never be zero. So AC is equal to zero. It's impossible. It's not possible. It doesn't make sense if you say AC is equal to zero and the object moves along a circular track. It's pointless, right? So AC never becomes zero, whether the speed changes or not. So AC, I told you, AC is independent of, let's say, speed. AC is independent of magnitude of velocity. Number 4, variation of direction leads to, look here, variation of direction, right? Variation of change in direction leads to what? Change in direction of velocity, actually. Change in direction of velocity leads to centripetal acceleration, but variation of speed results in AT. Variation of speed means increasing or decreasing velocity, speeding up or slowing down, right? Direction of centripetal acceleration is another subject. Let me explain it for you.